As you can see, I've already shown pretty much all my working out. I'll just talk you through it. So we have the figure shown, given by the parametric equations, x equals t squared minus 9, and y is t times 4 minus t squared. And we had to work out the coordinates of the points P, Q, R, and T. P and Q were where the curve touched and intersected on the x-axis, and we were told in the question that R and T were where the curve intersected on the y-axis, but we were told that point T was not shown in the sketch. So, starting off with the point R and T, that's where it intersected on the y-axis, so that's going to be when x is equal to 0. So I've taken my x equation here and I've made that equal to 0. And then I've factorised and solved that to find that that's going to be when t is 3 or t is minus 3. I have then plugged those values into the y equation to work out what the y coordinates are at those points. So when I plug t is 3 in, I get 3 times 4 minus 3 all squared. So that's 3 times 1 squared, which is 3. So that's the coordinates 0, 3. When I do the same thing for when t is minus 3, so minus 3 times 4 minus minus 3 all squared, that gives minus 147. So that's like way down here. So that's the t that's not being shown here. And point R is the coordinate 0, 3. Right, now for the coordinates P and Q, well, that's where y is equal to 0. So I've taken the y equation and made that equal to 0. And I can see here that I've got 0 from here or 4 from here. Plugging those values into the x equation to work out what the x coordinates at those points are. So plugging 0 and 4 into here. Well, 0 squared minus 9 is just going to be minus 9. So that's the coordinate minus 9, 0. So that's point P. Then plugging the 4 in. So 4 squared minus 9 is 7. So that gives the coordinate 7, 0. So that must be the point Q. And that's part A of this question done. Part B said that point S was a stationary point, so straight away that's making me think that the gradient is equal to 0. So the gradient, when we have parametric equations, we need to do dy by dt divided by dx by dt. Now, the x equation here, that differentiates easily. That's just going to be 2t. The y equation, the way it's written at the moment, I don't particularly want to differentiate that the way it's written. So I've just expanded that out first, down here, and then I've differentiated it. I've then got the dy by dt divided by the dx by dt. And that needs to equal 0 for the stationary points. I'm now going to multiply both sides by 2t, and that leaves me with the 3t squared minus 16t plus 16 equaling 0. I've factorised that and solved that to find two values of t. I've got the 4 over 3 and 4. So now I was thinking, well, which one of them is it? Well, this 4 here, there is a stationary point at when t is 4. It's this one here that we've already dealt with when t was 4 at the coordinate 7, 0. So we don't want that one. It is a stationary point, but it's not the stationary point S. That's the stationary point Q. So I don't care about t being 4. I want when t is 4 over 3. And then I've just plugged that 4 over 3 into the x equation here to work out the x coordinate, and the y equation here to work out the y coordinate, and that's what we needed to show.